Hi, and welcome to the video tutorials of the gmShiny app. I'm going to walk you through all of the basic functionalities of the app so that you can explore your geometric morphometric data in a user-friendly interface. So when you open up the app, the first thing that'll happen is a nice welcome screen will pop up and ask you if you'd like to keep the instructions on. And these instructions are just pop-up windows that'll help you understand the functionalities that I'll describe in this video. So for the purposes of this tutorial, I'll turn these instructions off. But if you are using them and you've forgotten what a certain pages for or some of the options, you can turn those instructions back on at any time. So we'll press a no there. As that happens, a different pop-up button alerts you to the fact that the instructions toggle is in the bottom left-hand corner down here. So we'll just hit OK. And now we are on the first page of the Shiny app, which is called the data input page. And here is where you're going to be uploading your data. We've got space for you to upload a shapefile, which can be in the format of a TPS or an NTS file. And you can also upload stereomorph files as well. You could also upload a phylogeny or a CSV or Excel file, including some trait data. Now, for the purposes of this tutorial, and if you want to practice without any data, we can use an example data set that is a part of the geomorph package. It's the pleth species data set, and that can be pulled into this app very easily just by pressing this use example plethodon data. And now we have a slightly different visual of the app, and we can see the shape data associated with that data set on the left, the phylogeny, and the trait data that are kind of made up data. We've got two sets of discrete data and a continuous set just to show some of the cool features of this app. On the left, you'll see once you upload a shape data file, you've got some options for how to read in and interpret that data set, and you've got a nice preview of those data to make sure that what you read in is what you think you read in. Same thing for the phylogeny, and we've got a little image of the trait data as well. In this third column, you also have some options of which of the trait data you want to move forward with in the app. And for this example data set, there are three options. There's a discrete example data set A, discrete example data set B that you see once I click that pops up into our preview down here. You can also include a continuous example data set. And with each of those selections is tacked on more of this CSV file that was uploaded. And for each of those data sets, it'll pull the name from the first line in that CSV file or Excel file as the name, and you can specify whether that trait is discrete or continuous. You'll see over here on the right, this continuous example data set is as you might think, a continuous data set. And so with that, you are also given the option to transform those data either using a log transform or a square root if you want to do that before moving forward. And that's basically the gist of the data input page. There are a couple things that would pop up if you're not using this example data set. So for instance, if you upload a shape data file and a trait data file where the species or the specimen names don't match together, there will be a button that pops up that asks you to prune those data sets to one another. So it'll eliminate any of the pieces of data that are not represented in all of your uploaded files. And that's a button that you'll have to press before moving forward, but that is only necessary, like I said, if it pops up and if your data sets don't match before moving forward. Welcome back to the video tutorials of the gmShiny app. Here we are just leaving the first page, the data input page, and we're going to be moving on and talking about the data prep page. For the purposes of this video, we'll still be using the example pleth species data set that we loaded by pressing the button that was up here in the top right. But moving on to our data prep page, this takes us to a page where we have a few tabs here, 3 different tabs that give you some options to manipulate your data before moving forward with some more fun analyses and plots. The first tab we have here is called Define Links and the Semi-Landmarks. So like that name says, this is where you are going to draw out the links that will be applied to the rest of the plotting features throughout the app. And this is also where you define your semi-landmarks. The links can be defined fairly easily just by clicking on the landmarks that you want to connect. So single click all of the ones that you want to connect. And when you reach the end of a line that you want truncated, you just double click and that'll be the end of that link. You can add a second link by, again, just single clicking some of the landmarks that you want to connect and double clicking when you're all done. Easy enough. You can reset those landmarks using this button as well. The semi-landmarks are defined in one of 3 ways. You can upload a file that is a CSV or an Excel file from your computer. This will have to be in the format of 3 columns, where the first column and the third column are the landmarks between which the semi-landmarks would slide, and that middle column is the actual semi-landmarks themselves. You can generate that CSV or Excel file using geomorph. There's a function in there that can help you do that, or you can just write one yourself because they're fairly simple. If you don't want to upload a external file, you can manually assign semi-landmarks by editing in this table itself. Here you want to start by defining the semi-landmark itself and then defining the sliders around it. So say, for instance, we wanted landmark 3 to slide between 1 and 5. We would put 3 in here, and then for the values outside of 3, they're going to be 1 and 5. And you'll see that as we filled that in, the colors of these dots changed a little bit to match their new definitions. And the color options can be edited down here. We've got an option for how to color the semi-landmarks themselves. So we could change that to, let's change that to a burnt orange for the purposes of here. The brackets would change the colors of the landmarks around any semi-landmarks. You've got several other color options there as well. The last way, and I believe the easiest way to define semi-landmarks, is directly on the plot, where you can just click and drag over the landmark that you want to define as a semi-landmark. And the neat thing about this is that if you've already defined links on this plot, it will transfer that information into that semi-landmark matrix for you. So if you've noticed, as I let go of that drag and click, 9 was defined as a semi-landmark in here, and the links that connected 8, 9, and 10 were used to define the sliders or the bracketing landmarks along which 9 is going to slide. Now, if you have links and they don't perfectly align with where you want your semi-landmarks to slide along, that's okay. You can always edit this semi-landmark matrix manually after the fact. So say I wanted it to slide between 10 and 7 for some reason, I could just edit that manually, and that'll apply to the plot. Once you're happy with your semi-landmark matrix, a very important step is that you apply the semi-landmark matrix with this dark blue button. This will run a series of checks to make sure that your semi-landmark matrix is in the appropriate format. There aren't repeats that shouldn't be. There aren't landmarks outside the scope of your data set, etc. And this is going to be something that's put into the generalized Procrustes alignment in the 3rd tab of this page. But before leaving here, you must press this apply semi-landmark matrix if you have any. And you might have noticed when I pressed that, some of the semi-landmark smaller gray dots shifted a little bit, and that's an indication that the button was pressed, and we can move forward. The next tab here is the Visualize Outliers and Individual Specimens, and this is a great tab for us to do a check to make sure our shape data were collected correctly. The first plot that you see in this tab is generated from the function plot outliers, and so each of these dots is a specimen, and it tells you how far from the mean that specimen is to indicate which specimens may be outliers. Now it seems based on this plot that maybe this dot over here represents a specimen that is too far outside the norm to be considered a correct reading of the data. So we might want to inspect it before moving forward just to make sure. Now we can do that by clicking on it, which will open up a plot below there and scroll you down to visualize that specific specimen. And it tells you up here that that specimen was labeled P. natingi. However, looking at it itself, it looks like the right shape. It doesn't look like any landmarks were made incorrectly or it's a weird enough plethodon head to exclude from the data set. So we might not do that before moving forward. However, that is an option for you. And if you'd like to exclude any of the specimens, you can do so with this pull down menu here. It'll give you a list of all the specimen names, and you can select whichever one you'd like to remove from the data set and press this remove button. And below that, a little button will show up to indicate which ones you've pulled out of your data set. And this has removed not only the shape data for P. shenandoah, but also the phylogenetic and the trait data for that specimen. You can also look at the names on these plots to see which specimens are falling along this plot. And you can also visualize outliers by trait group instead of looking at all of them together. If you've uploaded any discrete traits into your data set, you can specify which specimens you'd like to look at in this visualize outliers plot. So defining traits based on the discrete example data set A, we can look at levels 1, 2, and 3. You could also do this for this other discrete data set where we've got just 2 levels, level A and B. Moving on to the last plot, the last tab of this page, it's called generalized Procrustes alignment. And if your data have not yet been aligned before coming into this gmShiny app, this is a must hit. You cannot move forward in the app without aligning your shape data. So this serves as kind of a last check before we officially run that generalized Procrustes alignment. And so on the left, we've got a preview of the raw landmarks as they were imported and a summary of the things that need handling before running the GPA. These 2 options here correspond to 2 of the options in the function GPA gen. Here we've got a list of the specimens that we've dropped. If we had any missing landmarks to estimate, it would be listed under this part of this tab. And then down here we have that semi-landmark matrix that we created earlier in this video. If everything looks like it should, you can just hit the run GPA, and that will actually, now moving forward, we'll use just the aligned landmarks. And this is the preview of those landmarks. Now you may have noticed that some of the plots that we've passed through and some of the results we've passed through have some export buttons associated with them. And these are generally available throughout the app in order to allow you to just copy the PDF of the plot or a CSV of the results that you're seeing with this export plot button. You also have over here an export plot button for the define links and semi-landmarks if for some reason you want to capture this PDF. And you also have the option for exporting the code, and this code will allow you to recreate this in the actual R environment. So if you'd like to take this app and move to geomorph in R or RStudio, you can export the code that will help reproduce this plot. And if you do so, you also need to press this export current data. These 2 things are necessarily tied together. This will give you the code to reproduce this plot, but the current data are informing what options are selected in that code. So both need to be downloaded at the same time in order to reproduce said plot in R or RStudio.